projection projection representing in dimension object in minus one dimension is projection. Projection can be divided into parallel projection, perspective projection. Parallel projection can be divided into um, what parallel projection can be divided into oblique, orthographic and oblique. Oblique can be divided into three: isographic, um, orthometric, projection is representing n dimension, representing n dimension object in n minus one dimension is projection. Projection can be divided into parallel projection, perspective projection. Parallel projection can be divided into two: oblique, orthographic. Orthographic can be divided into two. Orthographic can be divided into two: multi-viewed or axonom, axonometric, orthographic, multi-view, axonometric, isometric, diametric. Oblique can be divided into two: cavalier, cabinia, likewise. Perspective projection, 1 point, 2 point, 3 point. Parallel projection. A projection is said to be parallel projection when if center of projection is at infinite distance with the projection plane. That parallel projection, candidate position are transferred to the viewplane along the parallel lines. Candidate points are transferred to viewpoint along parallel lines. Perspective projection, the distance from center of projection and projection plane is finite. Perspective in perspective projection, difficult to determine the size, exact size and shape of the object. Visual effect is similar to the human visual system. Object appear smaller as distance from center of projection increases. Object appears smaller as the distance from projection plane. Distance from center projection increases. Object appears smaller as the distance from center projection increases. Orthographic projection. The direction projection, parallel projection, perspective projection. Parallel projection can be divided into orthographic, oblique. Orthographic can be divided into multi-view, axiomatic. Axiomatic can be divided into three: isometric, diametric, trimetric. Oblique can be divided into two: Cavalier, Cabinia. Cavalier, Cabinia. I don't know what it is. Cavalier, Cabinia. Perspective projection can be divided to 1.2, 3 point. Projection is representing n-dimension object in n-1 dimension. Parallel projection means when center of projection is in infinite distance from the projection plane. It is called parallel projection. When projection plane is in projection plane is situated in finite distance with the center of projection. It's called perspective projection. There are two different parallel projection: oblique, orthographic. Orthographic projection is when the lines are the direction of projection is normal. The direction of projection is normal to the projection plane. Direction of projection is normal to the projection plane. Direction of projection is normal to the projection plane. Direction of projection is normal to the projection plane. There are three things: front projection, up projection, side projection. Front, top, side projection. Just as orthographic lines are parallel to each other, orthographic lines are parallel to each other, making an angle of 90 with view plane. Orthographic lines are parallel with each other, but it makes 90 degrees with projection plane. Projection plane. Orthographic lines are parallel with each other, but it makes 90 degrees with projection plane. Orthographic projection is this. Orthographic projection. When viewpoint, the direction of projection is normal to the projection plane. Front, up, side. Three types of orthographic projection: front projection, up projection, side projection. Orthographic projection, orthographic lines are parallel to each other, but it has 90 degrees with projection plane. Oblique projection, the direction of the projection is not normal to the projection plane. The direction of projection is not normal to the projection plane. In oblique projection, we can view object better than the orthographic projection. In here, we can view the object better than the orthographic projection. There are two types of oblique projection: Cavalier, Cabinia. Cavalier, cabinet. Oh. I have memorized wrong things. Cavalier, cabinet. Cavalier, cabinet. Cavalier, cabinet. Oblique, two types: Cavalier, cabinet. If the past paper, let's see whether this is exactly in the past paper, but because it seems like I haven't even heard about that. Transformation matrix and origin from the type transform the sharing of movement transformation. I think this is not needed to study. What is solution is a reference value. Those are not in the paper. What is projection? Hey, what is projection? Distant analysis is parallel and perspective projection. Physical analysis. They are not asking that much of questions in parallel projection. But somehow I need to memorize all this. Otherwise, if it comes to the exam, I will be devastated. Yeah. There are two Cavalian in 90 degrees, 45 degrees. The cabinet is for 63.5 degrees. Lines are object length will not change. Object length is a line of the object length will not change, but here it will reduce down to half of the length, half of the actual length. Half of the actual length. This is line of the object length will not change. Line of the object length will not change. Line of object length will not change, but here half of the actual length. 1 point is simple, 2 point give better, 3 point much difficult to draw. I don't know what is going on. Okay, that's it, that's only about projection. That's it about projection. Finally, projection. Projection. What is projection? Projection is representing in dimension object in n minus 1 dimension of projection. There are two types of projection: parallel projection, perspective projection. Parallel projection is when the center of projection and object are in infinite distance. Perspective projection is when center of projection and projection plane are in finite distance. Parallel projections can be divided into which are oblique and orthographic. Orthographic can be divided into multi-view and axiometric. Axiometric can be divided into isographic, diametric, trimetric. Oblique can be divided into cabinet, cabinet. Is like difference between orthographic and oblique is the projection is say the direction of the projection is normal to the projection's length in orthographic, but in oblique the direction of projection is normal to the projection's length. Three types of orthographic projection are up, front, up, side, oblique projection, the direction of projection is normal. Comparative curves. Run from the sunlight, run from the sunlight, tracking love. 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 Comparative curves. There are three types of curves: implicit curves, explicit curves, and parametric curves. Implicit curves, explicit curves, parametric curves. Implicit curves are the points are in the on the curve. Explicit curves are I don't know what are those. I'm not mentioning anything now. Points are on the curve is implicit curve. Explicit curve is points are not on the curve. Fx y සමාන බිවි y මෙතන y සමාන fx. Parametric curve කියන්නේ the dimension parametric not everybody I don't know. They have not mentioned it properly. So parametric curve example එකක් තමයි bicycle and B-spline are examples. I think bicycle can define control point. Defined by bicycles are defined by control point. Curve which starts from the starting control point and end with the ending control point, and then that drawn using those 2 points and other 2 points in 3 points points and control point. If there are control points minus 1 is the degree of the function of the curve. Points are not allowed on the curve. Curve equals to the points are not allowed on the curve other than starting and ending point. If it is not a starting and ending point, points are not allowed on the curve. 2 points linear curve, 3 points quadratic curve, 4 points cubic curve. These are anchor nodes, and these are handles. Anchor nodes, handles. These are anchor nodes. The starting and ending points are these are anchor nodes. These are handles. Anchor nodes, handles. Properties of bicycle. It always passes through the first and last control points. These are properties of bicycle. It always start and end with the. It always start and end with the. It always passes through the starting and first and last control point. They are containing convex hull. They are containing convex hull. They are containing convex hull. They are contained in convex hull. Convex hull. It always passes the first and last points. They are contained in the convex hull. Convex hull means this, the polygon shape that we made using the control points. We call convex hull, and it always contained in the convex hull. The degree of the polynomial defined in the curve segment defined by the one less than the number of control points. The shape of the polygon usually followed by the bicycle. Bicycle are tangent. They are first and last of the control polyline. Bicycles are tangent to first and last edges of the control polyline, which means we start from there and end there. Bicycles exhibit global exhibit point means moving a control point along the shape of the whole curve. Bicycle exhibit what? Exhibit global exhibit point. Global exhibit point. Global exhibit point. Global exhibit point. Bicycle exhibit global exhibit point means moving a control point alerts the shape of the whole curve. Change in one point can change the whole shape. That is it. So derivation of the bicycle means PU samanai P I, yeah, sigma I goes to 0 to n Pi B I N U. B-I-N-U. PU equal to sigma I samana binduina ennanakam PI BINU. So BINU is equals to N ක්‍රමාවලිය දෙදීම ක්‍රමාවලියට I ක්‍රමාවලියට x to the power I 1 minus u to the power I 1 minus u to the power n minus I. If it is a cubic bicycle, what you're gonna do is we're gonna replace a 3 in the place of n, and we can write this pu like this, and b like this. B0 is 3 B03U is this, B13U is this. Likewise, there can be several equations. Final bending function is this. So if you want to find out PUX, PX, PY, likewise there can be 2 points. Yeah. Yeah, it was U goes from 0 to 1. U will be in between 0 to 1. and we can decide the gap in between in our decision. It is in our decision, so in here we decided it is 0.2, 0.6, 0.8 and 1. So according to that, we have two equations for pux and puy. So we're gonna substitute in here each time, and we're gonna find the values to it, and then we can draw the curve. We can draw the curve. B-spline. The difference between bicycle and B-spline curve is B-spline curve has local control, while bicycle has global control, which means B-spline curve, it divides curve into few segments, and if some kind of difference is made, that segment will only be affected, not only the whole global curve, only that segment will be affected. Order of the polynomial based on the number of control points. If order varies, then any function it will be different. Bicycle curve is like this. It starts from this and end with this, and it goes like this. But if you change one point, the whole shape will be different. But in B-spline, there are these type of points, and we have drawn it like this, the curve. But we have divided into some segments. So if you are changing this point in to here, the curve shape will be changed only in this segment, but none other things will be the same. The properties of B-spline, these need to be memorized. It is first of all the sum of B-spline basis function only parameter equal to sigma I සමාන එකේන උදාහරණ NIKU is equal to 1. Properties of B-spline. The sum of B-spline basis junction at any parameter u equal to 1. Sigma I සමාන k නම් n plus 1 වෙනකම් NIKU සමාන 1. Sigma I සමාන k නම් n plus 1 වෙනකම් NIKU සමාන 1. n plus 1 number of control points. K order of B-spline curve. Sigma I සමාන k නම් n වෙනකම් n plus 1 වෙනකම්. Sigma I සමාන k නම් n plus 1 වෙනකම් NIKU is equals to 1. NIKU is equals to 1. NIKU is equals to 1. Sigma I සමාන k නම් n plus 1 වෙනකම් NIKU සමාන 1. NIKU is equals to 1. N plus 1 is number of control points. K order of B-spline curve. Okay. The basic function is positive and 0 in all parameter values, except for k is equals to 1. K එකයි නම් දන්න නැහැ. NIKU කියන කෙනා බිඳුවට වඩා හැම වෙලෙම විශාලයි. හැබැයි මෙයා k සමාන 1 වෙලාවෙදී එහෙම වෙන්නේ නැහැ. Each basic function has one maximum value. The maximum order of curve is equal to the number of vertices of the defining polygon. The degree of B-spline polynomial is independent on the number of vertices of defining polygon. B-spline allows the local control over there is a big equation. I need to should I memorize this? This is very big. What do you think? Should I just memorize this big equation? Not possible. Why should we memorize all this? There should be logic behind this, so that we can memorize it. We don't need to memorize those things. But anyhow, I need to memorize it. I think I'm not gonna memorize this big thing. Stupid. NIKU is equals to this. Q is equals to I goes to 0 n plus 1 PINIKU. NIKU is this big equation, and later on I will memorize it. Now, so if it is 0, I don't know, man. Okay, I'm gonna move on with that because it seems like, yeah. When we're designing B-spline curves, we don't have to evaluate knot vector based on the number of control paths or order of curve. When we're designing the B-spline curve, we have to evaluate knot vector based on the number of control paths and order of the curve. Number of baseline paths and order of the curve. Number of baseline paths and order of the curve. Knot vector can be evaluated by using uniform, non-uniform, open, uniform. I don't understand this. What have we more? 2D transformation. Now 2D transformation. Transformation is creating, changing the object after creating. Changing the object after creation is transformation in terms of position and size. In terms of position and size. Changing of the object after creation in terms of position and size is transformation. So there are 5 types of transformation: translation, rotation, reflection, shearing, ridging. Shearing, what are the things? Scaling. There is nothing like splitting. Yeah, dear. Learning. 관자반을 터치기 전에 내 맘이 난 놓치기 전에. Translation, rotation, scaling, rotation, scaling, shearing, reflection. Transformation is changing of one object after creation in terms of shape and size. Translation, rotation, reflection, shearing. Translation, it will shift the object from one position to other position. It will change the object from one position to other position. So when I thought you could name.